Hi statistics group, it's Miss O'Neill. At this point you guys should have had a chance to look through the notes that Mr. Parada has uploaded where it focuses on adding fractions. There was 2 sides. He gave you your rules off to the side, and he also at the ending of the question gave you one of the trickiest things that he could give you, which is where it's got that -1 inside of your parenthesis that you're going to have to remove to be able to complete the problem, okay? So the assignment sheet that tags along with this looks like this. There are a total of 8 questions on it. The ones that you're going to have to focus in on that could be the trickiest are questions 4 and 6. Both of them have that backwards variable switch, which means you're going to have to remove the -1 from that situation first and then figure out what remains when you take out the -1. So again, if you are having difficulty with that, you should be looking at your notes. Question number 3 helps walk you through that example, okay? Today I'm going to focus in on 2 of the 8 questions. I'm going to be doing question number 6 with you and question number 8, okay? You should be working on these assignment questions on another sheet of paper. Then when you are finished, take those copies, make sure you take a picture, and then email it to Mr. Parada or I, okay? So question number 6. One of the first things that you are told to do is to factor out your bottoms, all right? As we look at this first example, it's got 2 terms, so it's either GCF or it's dots. Neither one of these have anything in common, so we're going to have to draw our 2 parentheses, and we're going to be using our dots, where we break up our x squared into 2 different parentheses, and we have to think about how to break up 25 into 2 equal pieces. 5 times 5 gets us back to 25, and they're the equal factors. One of them has to be plus, one of them has to be minus for us to stay a negative when we multiply. When we jump over here, this is that little trick that Mr. Parada had cautioned you guys in your notes with. Because it's got a -1 hidden in here, my signs aren't the same as what I see over here. Many of us are going to think that, oh, I should be able to cross those off soon because of the fact that it's got the x and it's got the minus and the 5. Wrong order, can't do it. So first we take out that negative sign, and then when I remove the negative from the x, I'm left with just an x. But if I take a sign from the x, I have to take a sign from the 5. So that +5 is going to turn into a -5. And if you want to double check that you did this correctly, -1 times x is a -x. -1 times a -5 is a +5. So once you have this, you've done step number 1. You've factored out the bottoms, and you need to look for how to make them become the same. So if I'm looking, both of these share an x minus 5. This one is missing an x plus 5. This side is missing a -1. So both sides have to be multiplied by the factor that is missing. So I'm going to throw a -1 over here. And if I did it to the bottom, I'm going to do it to the top. And I'm also going to jump to this side and give each piece an x plus 5, top and bottom. Now, Mr. Parada is usually the one that just takes the matching bottoms and makes it into one giant problem. I'm going to show you how to do a step in between in case it's a little overwhelming at first. So on our top fraction, we have -1 times 10x is -10x. And we have our bottom piece just being rewritten. You don't have to distribute or do any box method, just rewrite it. Carry down that plus sign. 5 times x, 5 times 5. That's an example of that distributive property. Okay, so that has gotten our tops to be simplified, so now that we can combine them together. If you're taking a look, your bottom pieces end up matching perfectly, which means you can now make your single fraction. Mr. Parada usually skips this in-between step and jumps right to here. If you're a person who likes to organize yourself a little bit better and break up that step first, it's up to you. We're going to take -10x plus 5x plus 25. Once you have simplified your tops, you are looking for anything that can be combined. If we look at the top pieces, we have a matching variable of an x, so negative 10 plus 5x can be combined to give you a negative 5x. Carry over that plus 25, and this will be our new top piece, which means this no longer exists. There is a last and final step, and it's to determine whether or not you have to simplify or you have to go and factor or cancel something out. The bottom is already broken up. We're going to have to re-break up the top. So our top, if I look at it, shares a 5, and in this case, I might even want to pull out the negative, okay? If I do that, I'm left with that. Double check your math. Negative 5 times x, negative 5x. Negative 5 times negative 5, positive 25. And that's all over the bottom, which we have done nothing to this entire time. Looking for pieces to match. And believe it or not, a negative divided by a negative crosses off. So we are left on top with just a 5. And on bottom is a 1, which you don't have to write, and an x plus 5. If you're feeling like you are stuck, you should be asking questions. Make sure that you're reaching out to Mr. Parada or I, okay? And so that is question number 6. Moving on to question number 8. Number 8, a little bit longer, not as tricky in the sense of things aren't really flipped backwards, but you are going to have to take the time to look at your process and double check that you are getting the bottoms to match completely. Since there are 3 pieces, all 3 pieces have to have that one giant bottom that matches all the way across, okay? Starting with our first fraction, we need to figure out what these are broken up. So because it's 3 pieces and they don't share anything in common, this is automatically your 2 sets of parentheses. We know we will have an x in each column, and you'll be thinking what times what can give us 10, but then adds to a 7. Our factors of 10 are 1 and 10 and 2 and 5. 1 and 10 are not giving us 7 when we add. So we're going to put a 2 and we're going to put a 5 in there. Our signs will both be positive because our trinomial is positive. And so when I'm looking, this has an x plus 2, this has an x plus 5. Our middle piece, middle fraction, is missing an x plus 2. Put it on the bottom and the top. And our last one over here is missing an x plus 5. Okay? So at this point, if you are used to what Mr. Parada is doing, he has drawn his giant fraction, and on the bottom is going to be that matching set of each piece that we are going to carry over. Okay? So to show an example of that, we are going to have an x plus 2 here and an x plus 5. And you're doing it step by step. In our first fraction, we've multiplied by nothing, so that 9 stays. And our second fraction, we are taking a positive x plus 2, and we're trying to give it to the 3. Because you have 2 pieces, this is your double distributive property. 3 goes to the 2 and to the x. So that would be plus 3x plus 6. Last but not least, careful with that subtraction of that fraction. This is a negative 1 going to an x going to a 5. Negative 1x minus 5. And so from here, you're trying to think about that idea. Is there anything I can combine together? We have a 3x and a minus 1x. That would be 2 x's when I go and combine them. Now we're going to look at 9 plus 6, take away 5. That will give us a total of 10, and it's going to be positive. So this piece no longer exists because you've combined your like terms. And at this point, you may want to stop, but before you can, double check. Can I do anything in terms of breaking this apart further? If you can, you should, because there's something that you're probably going to be able to cancel. This 2 and this 10 both share a factor of 2, so we'll take that out, leaving behind an x plus 5 over x plus 2, x plus 5. We see our matching pieces can be canceled out, leaving behind on top a 2 and on bottom an x plus 2. And here's your answer for question number 8. If you come in across any other questions within this document, please make sure that you're reaching out to Mr. Parada and I, and let us know how we can help. Thanks.